In this video, we will do an example where we talk about how to count elements when we have 3 overlapping sets. So the example says 75 science students were surveyed, and 26 like biology, 34 like chemistry, 13 like anatomy and chemistry, 10 like biology and chemistry, 9 like anatomy and biology, 5 like none of these subjects, and 6 like all 3 subjects. How many like anatomy? Okay, so we have all of these pieces of information, and to get us started, let's label our sets. So I have these subjects: anatomy, biology, chemistry. So maybe I will let A be the set of students who like anatomy. Recall that I'm putting these curly brackets around this to indicate that this is a set. The way I read this is the set of students who like anatomy. Similarly, I'll let B be the set of students who like biology. Maybe I'll just write bio for biology. And then C is going to be the set of students who like chem. I'll write chem for chemistry. Okay, and as we've seen with these types of problems, it's usually helpful to draw a Venn diagram. So let's draw a Venn diagram. All right, so I'm going to zoom out a little bit so I can see the problem still and get my diagram started. So I'm going to have a circle for A for anatomy, a circle for B for biology, and a circle for C for chemistry. And these circles may overlap because there could be students who like multiple subjects simultaneously. And all of these are within some universal set, which I'll call U for this with this rectangle. Okay, and let's start inside out. That's often a good strategy with these. So start inside out. And in this question, it tells us, well, there's 6 students who like all 3 subjects. So that means we put a 6 in this region where all of the circles are overlapping. And there's one other value I can actually really quickly label in this diagram, although it happens to be the most outside value, because the question says that 5 students like none of these subjects. So let me just put that down. So 5 students are going to be outside of all 3 circles. I know that's not technically working inside out, but it just seems really simple to label that, so I'm going to get that out of the way. So if we continue to work inside out now, it would be helpful to be able to fill out regions like this that are close to the 6, close to the most inside part. And that region that I've just highlighted, that's part of the overlap of circle A and circle B. So it's part of the intersection of A and B. So let's, in fact, think about the intersection of A and B. So the question tells me that, let's see, there's 9 students that like both anatomy and biology. So that means for that whole intersection region, I would have to add 6 to some unknown number. That unknown number was going to go in that highlighted region that I had drawn in earlier. But those 2 things should add up to 9, because it tells me there's 9 students who like anatomy and biology. So I can see that, well, the number that goes in the blank is a 3. That means 3 is the missing value here. If I add the 3 and the 6 together, I get 9, and that's how many total students should be in that intersection that like both anatomy and bio. So if I keep doing similar things, I could maybe next look at the intersection of B and C. So for that one, I would have to add 6 to some missing number. And there are 10 students who like both bio and chem, so this should add up to 10. And I can see that the number that works there is 4. 6 plus 4 equals 10. So the 4 is going to go here, that missing part of the intersection of B and C. All right, so I'm going to move a little bit more quickly through the last one. if I do A intersection C, that region, I would get 6 plus some missing value. And how many students like anatomy and chem? Well, 13 do. And I can see that 7 is the missing value there. So I would put a 7 here. Alrighty. So next, the question tells me how many students like each of the 3 subjects kind of individually. Like how many like bio, how many like chem, how many like anatomy. So for example, if I focused on bio first, all the values in the bio circle should add up to 26, because 26 students like biology. So if I take the numbers that I already know in the circle, like 3 plus the 6 plus the 4 plus a missing number, the missing number would go in this region over here. That should add up to the 26 students who are supposed to like bio. And after doing some quick computation, I can see that this is going to be a 13. So 13 goes here. Okay, so now maybe if I do the C circle next, if I add up all the values in the C circle, I'll get 7 plus 6 plus 4 plus a missing number. The missing number would go here. But those need to add up to, the question says 34 students like chem. And if I work this out, this box ends up needing to be 17. So 17 goes there, and giving myself some room. If I do A now, and I add up all the numbers there, 3 plus 6 plus 7 plus a missing number for that other region of A. Well, how many students like anatomy? Well, the question actually doesn't tell me. That's what I want to find. The question was how many like anatomy. So I scroll it down here. We actually don't know what this is supposed to add up to. That is what we're trying to figure out. Okay, so this isn't going to seem to be this doesn't seem to be helpful. So instead, what else does the question tell me? It tells me that there's 75 total students. So let's use the fact that I know how many total are in U. So if I add all these values I have, so we have 17 plus 7 plus 6 plus 4 plus 3 plus 13 plus that 5 plus this missing number. So I'm going to put a box for the missing number, or maybe I could put a variable there. That should add up to 75. And if we simplify this, this gives us 55 plus a missing number equals 75. And I know what that value has to be now. I can see that it's going to be 20. So we'd have to put 20 here. That's how many anatomy students are in that part of this circle. So we are ready to write down the answer. So how many anatomy students are there? Well, adding the numbers in that circle, we get there's 20 plus 3 plus 6 plus 7, which equals 36 students. There are 36 students who like anatomy. And I'm running out of room here a little bit, so I'm going to move my answer to the top of the page. And that is our answer. So in the next video, we are going to do another example with 3 overlapping sets. And that one, I'm going to give you the opportunity to try on your own first. It's a really good practice applying all the stuff that we've talked about in this section so far.